Hello everyone, myself Karimunnisa Shaik. I am from IT department at Marri Laxman Reddy Institute of Technology and Management. Today we will discuss about in concept learning we have a find this and candidate elimination. Concept learning is nothing but a task of acquiring potential hypothesis that best fits the given training example. Next, components of concept learning, instance space, hypothesis space. Hypothesis space is the most specific. Hypothesis can be represented in the form of pi. Most general hypothesis represented in the form of question mark. Semantically distinct hypothesis. We have these are the components. Next, let us consider a real-time dataset D where a person can enjoy a sport or not. Next, what this is the example in that how we need to find out a possible distinct hypothesis and hypothesis space and semantically distinct hypothesis space. Now coming to the example, in the sky contains we have a three attributes, that is sunny, cloudy and rainy. In air temp contains two attributes, warm and cold. Humidity contains normal, high. Wind contains strong and weak. Water contains warm and cool. And forecast contains same and change. Enjoy sport is a yes and no. Next, in the coming to the possible distinct hypothesis instance space, in this we have a in the sky contains three attributes. We have a four attributes. In that four attributes, three are different. Next, in air temp contains four attributes. In that two are different, warm and cold. Next, humidity contains normal and high, remaining two are high only. Next, wind is strong and weak, water is warm and cold, forecast is same and change. In this we need to select different types of attributes. How many are there? We need to count it first. In the sky contains three, that is I have mentioned here three. Next, air temp contains two, warm and cool, I have mentioned here two. Next, humidity contains one, two attributes. Wind contains strong and weak, two attributes. And the water contains warm and cool, two attributes. And the forecast contains two attributes, same and change. Two attributes I have mentioned. The multiplication of 3 into 2, 2 into 2 into 2 into 2 is 96. Next, the hypothesis space is in this the hypothesis contains we have a specific hypothesis pi and general hypothesis question mark. In every attribute contains we need to mention these two, specific and hypothesis, specific and general. These two attributes we need to mention. If we mention three, already sky has three attributes and we have two attributes more. What are those? Pi and general hypothesis question mark. If we add these two to 3, 3 plus 2 is 5. Next, 2 plus 2 is 4. Next, 2 plus 2 is 4. 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 So the multiplication of 5 into 4 into 4 into 4 into 4 is 5120. In the hypothesis space, we need to mention the general hypothesis and the specific hypothesis. Next, the semantically distinct hypothesis contains only specific hypothesis. There is no general hypothesis. So here we have mentioned 5. So 5 means we have added question mark and pi. So in this only one hypothesis we need to mention, that is specific. So semantically distinct hypothesis is 1 plus remaining. 1 is common, remaining 5 minus 1 is 4. So I have mentioned 4. Next, 4 minus 1 is 3. Next, 4 minus 1 is 3. Next, 4 minus 1 is 3. 4 minus 1 is 3. 4 minus 1 is 3. 1 plus multiplication of 4 into 3 into 3 into 3 into 3 is 973. Next, This is all about concept learning. In concept learning task, we have three types of learning techniques. One is distinctive hypothesis and the hypothesis space and the semantically distinct hypothesis. Next, the total possible hypothesis space is 5120 for a given data set. In this, the total hypothesis space is 5120 in the given data set, this data set. Next, let us consider few hypotheses that present in the data set is here. The sky contains sunny, cloudy and rainy, sunny. And the atom contains warm, warm, cold, warm. This is the data set. In this data set, we need to write down the representation. First is enjoy sport is a decision attribute. If it is a positive or negative, we need to check. If it is positive, we need to do in positive. Next, if it is negative, we don't need to do in a find this specific hypothesis. In the specific hypothesis, we need to represent only positive examples. Now, sunny, warm. The first attribute is sky. In the sky is sunny, air temp is warm, humidity is normal, wind is strong, water is warm, and the forecast is same. That is mentioned here. The question is, they have mentioned some hypothesis and we need to find out the best hypothesis is very tedious in this case. To over this problem, we used to algorithms. What was the algorithms are there? First algorithm is find as, that is nothing but a find specific, is one of the earliest simple algorithms in concept learning. It is designed to find the most specific hypothesis that is consistent with all positive training examples in a data set. The algorithm begins with the most specific hypothesis, where no value is acceptable, denoted by pi, and gradually generalizes it whenever it encounters a positive examples. So in the find as examples, we need to do only positive examples. Next, the algorithm in find as is initialize the hypothesis H to most specific hypothesis is capital H. Next, for each positive training instance X, for each attribute in a constraint AI in H, if the constraint AI in H is satisfied by the X, do nothing. Else replace AI in H, the most general constraint that is satisfied by a X. Next, the output of the final hypothesis H. Next, coming to the example, that is the algorithm. Coming to the example, in the sky, this is the question. In this, we need to solve the problem. First, the representation of hypothesis is initialized with this specific hypothesis pi. That is it is a specific hypothesis. Next, in this we have 1, 2, 3, 4, 5, 6 attributes. So we have mentioned 6 times pi in H naught. Initialize with the pi. 1, 2, 3, 4, 5, 6. 6 pi's I have done. This representation is a concept learning representation. Next, in the H1 is a sunny, warm, normal, strong, warm, same S. If it is a positive, then we need to do this first example. First, the consistent, the pi first is sunny. The specific hypothesis is accepts the positive, so it is a consistent. So the first one is the positive, it is a consistent hypothesis. Then we need to mention pi sunny, pi in place of pi warm, in place of pi normal, in place of pi strong, in place of pi warm, in place of pi same. We have mentioned. The next example is also positive, so it is a consistent. Next, if the same hypothesis, if the value is equal to the same in the input, in the instance of X, it remains same. If not, we need to replace with the question mark. First, in the H2, it is also S. So, sunny The H2, sunny. First is sunny, cloudy. Next, warm, warm, normal, high, question mark, strong, strong, same, warm, warm, same, 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 same. So, next, this is the sunny, the example. Sunny, warm, question mark, strong, warm, same. Next, in the H3 is sunny. The question is no. No, they have given. In this, we have, it is a negative example. So, we need to represent H3 is equal to H2. The H2 is sunny, warm, question mark, strong, warm, same. So, we have represented the same. Next, the fourth one is sunny, warm, high, strong, cool, change, S. This is the positive. So it is a consistent hypothesis. It accepts the positive. Next, the sunny. Next, warm is same. We need to compare with H2. H2 is equal to H3. So we need to compare with the H2. H2 is sunny same. Next, warm is same, warm. In the high and question mark, it should be replaced with the question mark. Strong, same. Cool, warm, different. So replace with the question mark. Change, same is different. So replace with the question mark. So in this, H2 is sunny, warm, question mark, strong, warm, same. It is a positive example, so we need to represent positive. We are expecting a positive. In this, the X1 attributes and X3, these are all the attributes is the question. In the question, they have all mentioned these three. The final hypothesis is, what is the final hypothesis? H4 is the final hypothesis. In this, mainly we need to do comparisons. If the same value appears, we need to write same. If the different value appears, we need to replace with the question mark. If the sunny is same, H2 is also sunny. So we need to write sunny only. If warm is same, we need to write warm same. That's the thing. Next. These are the references. Tom Mitchell, Machine Learning, Concept Learning, Finders. These are the references. Thank you.